Okay, the last section that we're going to talk about is 3.5. And you might say, well, we're in chapter 1. Why are we talking about 3.5? Because we're off. I'm doing this. It's Monday and we're off. No, I'm just kidding. 3.5 just blends nice with all these limit things that we've been doing. So this is the only section that I'm going to do before our test. Our test will include chapter 1 and this section, 3.5. And its limits at infinity, and I'm sure you can see, if you consider the graph 3x squared over the quantity x squared plus 1 as a function, it looks like a seagull. And if we look at the limits as they approach negative infinity and positive infinity, okay, you notice that you get 3 both sides. So one of the things we're going to look at in this section is taking a graph and sending it to the limit as it approaches negative infinity and infinity. And that's going to tell us something about the graph. Look at it. What do you see? I can't hear you. I'm just kidding. I know you're not saying nothing. Tells me I got a horizontal asymptote. Horizontal asymptote. We learned that when there's a 0 on the bottom, or something doesn't exist on the bottom, that's a vertical asymptote. Here, we send the limit to infinity and negative infinity and see if we got an asymptote. If those two are equal, it's a horizontal asymptote. Next slide. That's exactly what I just said. They have to be equal. And they have to equal the same number. Right here. Right here, folks. Same number. As I go from positive infinity to negative infinity. That's really positive. You want me to throw a plus sign in there for all you folk at home? There you go, all right? If you don't see positive, it's usually understood. Theorem comes up. Theorem. If R is a positive rational number and C is a real number, that means belongs to the real number. Remember, this means belongs to the real numbers. Then, if we have some number over a x to some power and it's going to infinity, then it's 0. The bottom of the fraction is getting ridiculously large, which means the whole fraction is getting smaller. Okay? And applies also to negative infinity when x is less than 0. Let's do an example. Holy cow. I know you don't get many examples, so here's one for the ages, I guess. Give me a second. Let me get it up on my notes here. I don't even know where it is. All right, I got it. Easy one. Limit as x goes to infinity of, let's say, the quantity. That's the quantity. It's a nice straight parenthesis, not to be confused with absolute value. I hope you guys are having a good day today. And that's what we're looking at. So the action turns out to be right here, folks. This guy goes to 0. Because the bottom of this fraction is getting very, very large. Fraction itself is getting very, very small. You don't believe me? Go to your calculator. Divide 2 by 100. And then divide 2 by 1,000,000. And see which one's bigger. Okay? So that goes to 0. So this is 5. I don't know why I put the equals 5 there to begin with. That's kind of because I knew the answer. General rule. There's a Marashio rule. You're going to love it. Let's take this away. If the degree of a numerator is less than the degree of the denominator, so the numerator, the degree on top is less than on the bottom, then the limit is 0 as I go to infinity, reminding you that this is all limits going to infinity. That's not my favorite infinity sign, but it'll do. If they're equal, let's say you have the same thing like x squared over x squared, or x to the 5th over x to the 5th. Then it's just the ratio of the coefficients. So like 5x squared over 10 over 7x squared would be 5/7. Just the coefficients, because the x squares will cancel. And the last one, if the degree on top is higher, well, guess what? I can't divide enough out, so the answer is does not exist. It may be infinity, it may be negative infinity, but that, remember, describes how it doesn't exist. If you write does not exist, that should be okay. All right? If they ask you to be, you know, if you get a multiple choice question, then you got to be as specific as possible. You know what? Let's do examples. What do you think? That's something you don't see from me very often, so let's do some examples. The limit as x goes to infinity, and we'll go of 2x plus 1 over x plus 1. So I'm looking and I say, oh my God, if I use that Marashio quick rule, these powers right here, I'll highlight them. These are the same. They have the same degree. The degree is 1. Remember, if you don't see the power, it's 1. So it told me it's going to be the coefficient, which is 2 over 1, which is just 2. If you want to see the behind-the-scenes math, this is only if you are a person that says, well, I want to know why. Well, here's why this happens. This is the why. This is for only those that care why. If I divide everything by x, okay? And now when I send it to the limit, this will be 0, this will be 0, this will be 2, this will be 1, and the answer is 2 over 1, which is 2, which is exactly what I had there before. So this is for the people that ask why does it work, or you can just follow and be happy here. I don't care. You don't have to show me what I've just written in red and blue. Let's do another example. Oh my God, you're getting crazy. I know. I know I'm getting crazy. I think I've been crazy. It's just that you need a little bit more, I guess. I don't know. I'm feeling good today, I guess. The limit as x goes to infinity, and that's what we're always talking about. X going to infinity. I will tell you that on your test or a quiz somewhere along the line, you're going to need to find if it has a horizontal asymptote or not. So that would be going to positive infinity and negative infinity as shown in the video, in the previous slides, I guess. So here, the bottom is greater than the top. So my answer here is probably going to be 0. Oh, you want to know why? This is why. And I'm going to do it quickly. We divide everything by x squared now. Plus 5 over x squared. We always divide by the highest power of x. I got to pause it. I got a phone call coming in. Nah, you know what? We'll take the phone call later. Here we go. I'm really not that popular. I get a phone call like once every 2 months. All right. This goes to 0. This goes to 0. If I cancel, this x cancels, and I just have 1x on the bottom. This guy's still going to 0, and these will cancel, so I'll be given like 0 over 3, which is 0. So you don't have to give me the y. You can just go ahead and do that one. Sound good? All right. Well, uno más of these type of problems, and I'll let you think about it. It's the limit as x goes to infinity of 2x squared plus 5 over 3x squared plus 1. So what are you thinking? Answer? Yep, 2/3. You got it. They're the same, so the answer just comes out to be 2/3. I'm not going to show the y anymore. Ooh. Sine graph. Nice, nice. I have no clue how to do the sine graph. Let me think. Sine's oscillating, right? 1 to -1? So it doesn't exist. We've got an oscillating function, folks. Here he is again. Oscillation. All right? Oscillation gives me no love. This is new. I'll put a little new here. This is probably going to be very new for you. The rest you can kind of get inherently. This one's going to be new. This one, we want to talk about, well, if I divide everything here, I'll bring the limit along. Remember, I always bring the limit along until I go through the limit. Okay, that's really ugly, but that's okay. At least I'm bringing it along. And I get 3x divided by x minus 2 divided by x all over. Well, if I had an x outside, to put it inside the radical would be to square it, because the square root of x squared is x. So if I had an x out here, to put it in here would make it x squared. Agreed? I hope you agree. Think of numbers. 5 on the outside, 25 on the inside. You square it. So that's what I'm going to do, folks. I am going to, eraser was quite large. I am going to divide everything by x. So yes, it looks like inside I'm also dividing by x. Nice, nice. Okay, so when I do that, up top, that goes to 0. That's 3. This goes to 0. And this is the square root of 2. So my answer becomes 3 over the square root of 2. Let me compare that. Let me make one quick change. One quick change, and I'm going to send this to negative infinity. How does that change the problem? Well, it changes the problem by doing this, I believe. We're still going to divide everything by x, but since we're playing with, so let's go to this step at least. We're going to divide everything by x. So we have this, the limit as x goes to negative infinity, 3x over x minus 2 over x, all over. Well, now, since I'm going to negative infinity, okay, I'm thinking about taking 2x squared and dividing it by negative square roots of x squared. Okay? So I'm going to divide by, actually, I think the kids told me, they told me this. Why don't you make the top one negative? And then the bottom, because it's in the square root, you keep it the same. So let's try that. Let's see if that works. And this is kids. All right? These are ex-students telling me this worked out a little bit better. So this goes to 0. This goes to the square root of x. By the way, this, if it's all, I don't want double square roots here. Come on, get out of there. Okay, that's better. It's all underneath the square root. It's all happy. So it's all underneath. Those go out. And then the top, this goes to 0. But this one becomes negative 3 over the square roots of 2. Because it's going to negative infinity. And you could graph it and check that out. But that's the difference. All right? If you're going to negative infinity, then divide by negative x. If you're going to positive infinity, divide by positive x. Let me show you another one. You might say, wow, that's crazy. Well, here's another one. Let's go to negative infinity to illustrate this. You would divide by negative x, divide this one by negative x, divide the bottom by negative x. Why? Because there's nothing going on in the denominator. There's no square roots or anything crazy. So it could be negative. The other one, the square root couldn't be negative. So that's why it was an issue. All right, that's the limit. That's limit, by the way. And now this goes to 0, this goes to 0. Those are easy. Negative 4, negative 3, and I get 3/4. Just what you would have thought. 3/4. So that negative only really matters when there's square roots going on, or something crazy like that. I think that's it. That's all I have time for, really. This is 3-5 in a nutshell. I do have homework for you. I want to check it. This is going to be it. It's going to be page 206, 205, 1 to 6. Matching. This is a matching portion. So they're going to give you a graph. They're going to give you some equations. You got to match them up. And then number 21 and number 45. Number 21 is just making sure that you're alive for this video. Alive and breathing. You know, nice. And 45 is rationalizing the numerator. So here's a couple of questions. Enjoy. And I will see you tomorrow.